All right, I think we are live. Welcome everyone to the HashiCorp Ambassador Thought Leader series, where we have our most esteemed community members and experts talk to us about the big ideas in our knowledge base. This means everything infrastructure, networking, application security, the entire life cycle and the management of it, techniques, principles, and the lessons that we hope you, the audience, can learn and make use of. So before we get started, obviously I have someone on screen that probably a lot of people recognize, but I do want to say for community guidelines, please make sure we want you to interact with us. We want you to ask questions and the like, but please check out our guidelines so that I feel like they're kind of obvious, right? Be inclusive, be welcoming, be friendly, but just in case that's confusing, we do have that right there. And our guest today, Ned Bellavance, as should be no stranger to anyone in the HashiCorp community. Now, would you like to introduce yourself?
Oh, yeah, sure. Hi, Cole. Nice to see you. I'm Ned Bellavance of nedinthecloud.com. I am a curious human, and that really is a motivating force behind everything I do when it comes to technology and just life in general.
So we also have someone else we're going to pull in here in just a minute, and it's kind of fitting given all the news surrounding HashiCorp today. But Ned's topic he actually wanted to pick today is also very fitting as well. So we're going to kind of do both. We're going to bring someone in new here, and we're also going to dive into this interesting topic with the title that's it makes you want to click it, right, Ned? It was a pretty good one. But what was the topic? Can you give us a little bit of insight into what you wanted to talk about today?
I've been thinking a lot about where we started pre-cloud, how we adopted the cloud, and where we go from here. And since AI is such a driving force, can AI help get us there quicker or more effectively?
Yeah, and that goes right in hand with other stuff that's been happening with HashiCorp today as well. So we wanted to bring on a third guest today. So let me go ahead and add him to the stage here. The one and only Armon. Would you like to introduce yourself for those who just happen to not know you for whatever reason in the Hashi community?
Sure. Well, thanks for having me and letting me crash the party on late notice here. I'm one of the founders, along with with Mitchell, and my role is CTO. But I'm more commonly, just a YouTube whiteboard influencer. So that's kind of my impromptu title.
Those are some. I mean, come on now. The whiteboarding videos. I think that may be in the first Hashi video that I actually saw before I even got in the company. So don't downplay. So we kind of wanted to set sort of Ned loose here a little bit, because Ned's got a lot of thoughts. He is a curious human, and this curious human I know has some questions for you, Armon, because especially around the big news that we had today.
Yeah, I saw this morning it's official that the acquisition by IBM has completed. So how are you feeling? Relieved? Excited?
Definitely relieved. It's been a year of lots of time with lawyers and regulators, which, you definitely start a tech company because that's your passion in life. So from that perspective, I'm very glad that we're sort of past that phase of it and into the actually fun part of building products and doing the integrations and getting to go back to the stuff we actually like to do.
Yeah, I feel like the whole year was just holding your breath, waiting for it to finish, and everybody's just chomping at the bit to get started on the next thing. So what is the next big thing? What do you see coming down the pike in the next 3 to 6 months?
Totally. Yeah, I mean, that's exactly what it was. It felt like we were all in purgatory, basically. We were waiting for it. I think there's a bunch of stuff that I'm excited about, right? I think on one hand, the mission of HashiCorp in a very important way doesn't really change. And I think that's important, right? And I think that was from the very beginning when we first announced the acquisition, we're the reason we're excited about this is because we see kind of eye to eye with IBM on hybrid cloud is the future and how do you enable that, basically. So that piece of it, I think, is important. What does change is basically right away, there's a ton of R&D investment that's happening. I mean, if you look at the HashiCorp jobs page, which I encourage you all to look at, it is, you can see the list is long, right? We've sort of opened up the gates wide. So you can tell there's going to be a lot of sort of focus on sort of growing the team and a lot of innovation we want to focus on. So I think there's sort of, I'll call it the HashiCorp standalone roadmap, which is very much how do we take what we're doing, accelerate our roadmap and do it faster? Then I think there's the sort of better together roadmap, which is, there's a ton of pieces that have become clear between Red Hat and IBM that are interesting. I think the near-term ones for us is really how do we bring Terraform and Ansible together? I think my favorite comment on this whole thing was not a terrible combination, which is my favorite one on this whole thing. So I'm super excited about that. And I think we've seen this already with users, which is like, hey, we already use these two things together. We even use both of those tools internally at HashiCorp, but they're kind of arm's length. So it's like, what would it look like to bring them much closer together and have an integrated workflow? So that piece I'm super excited about. And then it's Vault in the whole, I'll call it Kubernetes ecosystem, right? Like Red Hat is one of the biggest CNCF contributors. OpenShift is one of the biggest Kubernetes distributions. So we really want to make Vault sort of a first-class element of OpenShift and then drive the integrations into that whole ecosystem, whether you think about Istio, Argo, Flux, blah, blah, blah. Right? There's a whole bunch of pieces within that sort of universe that we want to integrate with. So to me, those are the big near-term ones that I'm super excited about. And we'll publish a blog post in the next few days talking about that too.
Yeah, the combination of Ansible and Terraform, I love that you brought that up because I was literally doing a consulting gig last week where I was talking to an architect and he was asking me for advice on how to integrate the two tools together. And like the answer was, okay, you can dump it out to a local file and then have Ansible pick it up and use the inventory from that. So that was like the easy answer, but it would be great if there was just a more integrated solution between the two tool sets. So
Exactly.
I
Exactly. And I
like
think there's a whole bunch of things, right? Like it's everything from like, to your point, it's that inventory generation, which is like, if Terraform's provisioning a thing, why isn't it just dynamically in Ansible's inventory? Or if we deprovision it, vice versa, right? Like it's just, that's like so table stakes.
Mhm.
And then when I think about even like Terraform provisioners, which we've supported since .1, right? Like the original launch of Terraform, they're a little long in their tooth, right? Because they really only work in select scenarios of life cycle. They're not super flexible. So I think there's a whole bunch of stuff where it's like, okay, can we actually expand some of that integration points in Terraform's core to make it easier to hook into various config management tools, not just Ansible, obviously Chef, Puppet, et cetera, but really focus on like, how do you make that a more seamless integration where today it's kind of like, I do this with Terraform and then I kind of go over here and do this with Ansible. And you know, it feels too disjointed.
Yeah, I've been using Terraform for long enough that I remember when there was a Puppet and Chef provisioner separate from the existing three that are in there now, but it was always a little awkward. So I'm
Yeah.
glad that, going back to the drawing table and figuring out a better integration point. Another thing that I wanted to ask you about is IBM has been making investments in AI for the last like 30 years. I mean, how far back does that playing on Jeopardy go? That was like 20 years ago or something. How do you foresee what IBM's been investing in with AI helping out what HashiCorp wants to do with hybrid cloud and all the other, cloud native tooling that you've put out?
So I think there's a bunch of interesting stuff. I think one of the things that people might have seen last year was like Ansible announced what they called Lightspeed, which is basically they worked with Watson X and the IBM research team to actually basically fine tune a set of models for writing Ansible. And they released that as a product feature called Lightspeed, where you can basically say, hey, write me a playbook to do X, Y, Z, and it'll basically generate the Ansible playbook for you, right? And they really focus on like, how do you fine tune it to avoid hallucinations and make it useful? I think there's a similar analogy, which is like, okay, how do you bring sort of that Lightspeed type capability to the Hashi portfolio? So you might say, hey, write me a Terraform script that does this, or write me a Nomad job file that does that. And how do we sort of have a set of fine-tuned models that really know the HashiCorp product domain and HCL to generate it in a way that'll be more reliable than just asking a generic ChatGPT type model to do it? So I think that's piece one, is when I look at the synthesis, it's how do we really work with IBM research and leverage the fact that they have like really deep AI ML experts to actually go build these fine-tuned models for us, which like that's just not necessarily a skill set that we were expert at.
Mm-hmm.
And I think we've seen them do that successfully with Ansible already. So that's kind of piece one. I think piece two then is the bigger vision is if you start thinking about all the data that we have between what does Terraform know about their infrastructure that you're managing? What does Packer know about the images? What does Ansible know about what's running on those VMs? And what does OpenShift know about what's in your Kubernetes cluster? How do we sort of bring that data together and then enable sort of AI-driven synthesis where you can actually ask it operational questions to say, hey, show me where do I have an open SSL vulnerability in my estate, right? Like what's impacted by Heartbleed? And I think today it's like those information exist, but it's in like 15 different silos. And it's sort of like, good luck, like kind of doing the 50 levels of data transform to get to that versus like, how do we actually pull that together and make that sort of a natural language AI-driven thing? So it's like, great, when tomorrow's Heartbleed happens, it's just like I can ask the AI and say, okay, show me what's impacted. Okay, great. Can you write me the Terraform and Ansible to remediate it? Okay, go apply. Right. And I think that's the kind of vision we want to work towards, and I'm excited about it.
Yeah, sort of closing the loop on the whole AI story. I think it's really important to differentiate a little bit between the different types of AI that are being leveraged in there, because it's not just Gen AI. You're not just using LLMs to do natural language querying. There's the whole traditional machine learning portion that goes on the front of that that ingests all this data and tries to make sense of it through. I'm not a machine learning person, so I'm going to screw up all the language. But that's the idea is there's a lot more to it than just the Gen AI flashiness that's happening now. But then you have the opportunity to take that information and the queries you've made and then use specially trained LLMs to then write the Terraform or the Vault policy or whatever it is to remediate the problem that you've discovered.
Exactly. Yeah, and that's why it's like I almost hate using the phrase AI. Honestly, I really do. It's me away from it because it's like I feel like half of what we see in industry, more than half, I'm being generous, is like pure smoke and mirrors. And so it's like I hate the phrase, right, for that reason. But I think to your point, it's like, yeah, to me, it's about what's the set of jobs to be done that a user cares about. I think about the operational lifestyle, of great, day one, I need to stand up infrastructure. But then day two, I have so many workflows around right sizing, patching, my disk is full. Like I have to recover an outage. Like to me, these are all concrete sets of workflows that day in and day out operators are dealing with. So
Mhm.
I look at those and it's about automating existing workflows. AI is one of many techniques. And so, yeah, I have Gen AI and LLMs as one tool in my toolbox. I might have more traditional, support vector machines or other ML techniques that are sort of other tools in that toolbox. And I think sometimes we get a little overhyped on the tool versus the workflow. And I think to me, it always goes back to the HashiCorp principles, which is workflows over technologies. It's like the thing I care about is like, you have a patching workflow, and great, can I automate that away from you? And maybe I'm using a combination of techniques. But at the end of the day, do you really care? Not really.
Right. Another area where I think AI is ripe to help out is that sort of day one adoption story where, okay, I'm starting with a blank piece of paper trying to adopt the tool set and automate what I have. Can AI do a deep dive into what I have today and then propose some workflows and some scripts that will help me get over the hump of the blank page problem?
So this goes back exactly to that notion of sort of like how do we do the data aggregation first to sort of like know what your estate is and sort of jumpstart the blank state problem. Because I think today the problem you have is like we have tools like Terraform import, but it's a
Mhm.
relatively manual, fairly arduous sort of exercise unless you have a very trivial infrastructure. So it's like, is there an opportunity for us to say, okay, if I could collect the data of knowing what your estate looks like, and then can I apply AI-ish techniques to sort of jumpstart you saying, here's what I think your estate actually looks like, right? Like, here's what I think is a reasonable Terraform, Packer, Ansible representation of your estate. Maybe it's not going to be perfect, but it might get you 95% of the way there versus starting at a blank slate, right? And I think that is a big thing we're looking at in terms of sort of accelerating that Terraform import type of a workflow from fairly manual to being highly automated.
I like the view, and I have a question for both of you. Right, AI is very, very buzzy as it is. Obviously, it's one of the main topics of the episode, the main topic, if that. But in speaking, I really like the perspective of it's just another way to get automation done. Do you think in the next few years we'll stop seeing it as this like hammer for every nail and more just, hey, it's another tool in the toolbox to get the job done, just like any other thing?
Sure. I want to go back to the fact that there are different types of AI, and you can use a different flavor of AI for a different purpose. And what I think we're seeing now is the maturation of the tool sets that will enable you to leverage these different kinds of AI. And we're still super early days in those tools. I mean, AI is a discipline that goes back, 100 years
Oh
almost,
yeah.
to the early theories. But the real big sea change that's happened is the enablement by hardware and then putting tools in front of users to get them excited, which has brought a ton of investment, literal, money into the AI space, which lets, 1,000 flowers flourish, or however you want to say it. Now we need to sort of narrow down to tools that are actually useful to the practitioner. And that seems to be like that's the phase we're going to enter next. But we have to have this big blossoming of all these solutions, some of which, like Armin, you said, are just smoke and mirrors and magic like pixie dust. Some of it's going to be real, though. There's some real stuff buried under all of that.
Yeah, no, I mean, I totally agree with it. I mean, my view is I've been through a few of these cycles now where it's like the technology for the scene, and all of a sudden everyone loses their mind basically, and they're like, it's almost like technology blindness, right? Like, I mean, 3 years ago it was crypto. It's like the number of times I heard enterprise blockchain, and I still don't know what an enterprise blockchain is or why it is, for whom it's for, right? And so it's like there was almost this craze where everyone lost their mind, and it's like, it's all you could hear about is that person. And before that was, I don't know, like NoSQL or key value databases or whatever. Like, we're going to throw away our database and replace everything with key value. You're like, why?
Yeah.
Like, why are you doing that? And so I think this happens over and over again. And then eventually we figure out, like, okay, nobody actually cares about your NoSQL database. Like, no customer's like, cool, love this SaaS service because it's using a NoSQL. Are you solving a problem of mine? Is it enabling me something to do something I couldn't do before? Are you automating something away from me? Are you, you have to solve a problem in the real world, right? A technology for technology's sake is rarely that interesting. I feel like we're in the middle of that right now for AI, where it's like, it's this sort of, it's everything to everyone. And yet when you sort of click in a little deeper, you're like, okay, but what are you really using it for in production? Everyone's like, no, nothing. It's like, it takes cool pictures for me when I use Stable Diffusion. Like, that's great. So to me, it's like, I think we're at that phase of it. And I think we're like, now we're going through that next part of the hump, which is, okay, you actually have to incorporate it and identify a set of concrete workflows that people actually care about and automate those. And then it becomes a boring technology that's just behind the scenes. And does somebody care if I'm using an LLM versus a neural network versus some other technique? Not really.
Right. Oh, that's a really good point, that depending on how you consume the tool, you don't necessarily care what's behind it. You care how effective it is at solving whatever technical problem or business use case you've got. When we were originally putting together this episode, one of the things that I was talking about was the fact that the migration of stuff from on-prem to cloud gave us the opportunity to fundamentally change how we construct those things. And we didn't do that for the most part. For the most part, we lifted and shifted the virtual machines up from where we were running locally and didn't take the opportunity to refactor those applications. And some of that was really justified because there was a cost associated with doing that transformation, that refactoring. And if you couldn't make a business case why it was worth investing the money to do this transformation, then it just was not going to happen. And I think 80%, I'm making up a number here, but I think a large portion of workloads that got migrated, no one found a business justification. And they're like, we'll do it later. And later never came.
Totally. I mean, I remember distinctly, there's a big financial institution we work with that they basically did an estimate of what would it cost for them to modernize their 5,000 internal applications. And the estimate was like on the order of $100 billion. And so for them, you think about a history of, they have technologies dating back 30, 40 years that are still in production. And so for them, they're like, okay, but like, what's the actual ROI of spending $100 billion on that modernization? And nobody could answer that question, right? So to your point, it's like their strategy was not to go do that. It was, okay, we're going to lift and shift large portions of this estate. And then there's a subset of applications that are net new development that we're going to do in a cloud native way, or apps that we're refactoring that we'll do in a cloud native way. But that might be 1,000 out of the 5,000. The other 4,000, we're just going to do a straight lift and shift.
Right, right. And I think what I was talking about with Cole was the fact that AI gives us the opportunity to maybe revisit the cost of what it would take to refactor some of these applications as the programming assistants get better at looking at existing code bases and can make suggestions that are more or less useful. And I brought up one example. I was talking to Joel Krusik, who's the federal CTO at GitLab, and he was telling me a story of a federal agency that he couldn't tell me which one, of course, but that they had a very old application that was running on premises, and they wanted to modernize it and move it onto a cloud. And they turned GitLab's coding assistant loose on it to help out, and they ended up migrating it from, I think it was written in C, migrating it to Rust, which is a big thing that federal agencies are kind of looking at right now. And the application was faster and I think it only took them about 6 weeks to do the migration, which is an insane
Dang.
timetable. And obviously that's not going to be the case every time. But the fact that they were able to take this application, make it run faster, refactor it into like more of a serverless architecture, and leverage Code Assistant to help them with, hey, this is what it looks like in C. Can you tell me what that would look like in Rust? That really accelerated and changed the timetable for what's possible for a migration.
I think we've seen a few interesting examples of this. Like Amazon showed off Q doing like a Java version upgrade, same sort of a concept where you might have an ancient Java app that's like on some old version that you need to modernize and pull to a modern version of JDK. And they basically showed the AI effectively automatically doing that with like a handful of asking the user, okay, what do you want me to do about X, Y, and Z? And I think IBM even showed an interesting one of like taking an ancient like COBOL mainframe app and basically porting it to modern Java as well. So I think you're right. It's like I think we're seeing a bunch of these sort of like cross language or even within language if you're going from old Java to new Java. But if you think about how much that cuts out from that modernization budget, right? Like what portion of that 100 billion would be just rewriting an ancient Java app to a modern Java app? And like how much of that could we like, take it from being $100 billion bill maybe to being like a $1 billion bill where all of a sudden that, actually does have real ROI.
So I think this is a really good sort of like top level overview of like the original thing, Ned, that you really wanted to step through, right? Because we just got the whole past, present, future kind of in a nutshell. But just to keep us like on the timeline, Ned, you brought a really cool idea that I'd love to get you to dive in deeper on, and then also Armon to also contribute to and dive into, which was cloud, how it evolved today, going more back to that past, right? Armon, your blog post you just released today, you talked about that entire vision, getting every HashiCorp product in every single data center, how it got to be. Ned, you talked about, hey, you've even mentioned some of the things, the big one being not just we've lifted and shifted and brought it to the cloud, but we also brought the concepts to the cloud too of on-prem. We're still thinking like on-prem in context of the cloud and how much that bothered you, and just sort of how we got there, how we got there today. Like why are we still thinking like that, right? So in terms of how it evolved into what it is today, Ned, could you elaborate what you meant by on that topic more?
Yeah. So if I look at some of the very early services that were offered in the cloud, it wasn't virtual machines. That wasn't the first thing that was being offered. The first things that were being offered were a queuing service, a notification service, S3, so some sort of place to put my stuff. And then when Microsoft launched Azure, the first thing they launched was not really a virtual machine. It was just a way for you to run .NET code on a cloud service. So you would just load your code into this cloud service. You give it some general idea of how big you want that service to be, and it would dynamically scale and recover. So it was very PaaS focused, platform as a service. And as the cloud got more popular, we started demanding as admins familiar constructs. Oh, I don't want just like these random services that I have to cobble together. Can you put it all inside like a network? Because I understand networks and I understand routing and subnets and oh, maybe we could just have virtual machines in there too, because I have these virtual machines and I know how to work with those and work with operating systems. I don't understand this PaaS thing as much. So I just want to move my virtual machines up there too. And so we just started repeating all of the exact same technology and terminology that we had on premises up in the cloud. And I think that was actually to our disadvantage at a certain point. And maybe the cloud providers should have pushed back and said, no, you should do it our way. But that's kind of what Heroku did. And it didn't work out great for them for a while. They're doing well now, but there was a long period of time where people were like, Heroku, it's too constrained, it's too opinionated. And people wanted the freedom, the flexibility, and cloud providers were like, well, we like earning money. So yes, we'll create that service for you. But I think in the longer term of things, it actually did us a disservice because it made it harder for us to bring the operational principles of cloud back on-prem, because instead we just had replicated what we had on-prem up in the cloud.
Yeah, I mean, I think there's this interesting balance between sort of revolution and evolution.
Yeah.
I think, to your point, the cloud gave us this very interesting and unique opportunity for it to be a revolution in how we built and delivered software. And I loved like the early vision of Azure was exactly what you said. It was the sort of VM-free PaaS the network went away. It was literally auto-scaled, global. You kind of didn't think about it. And under the hood, a lot of the technology was quite cool. There really wasn't VMs. It was truly almost a unikernel type design where they had a multi-tenant CLR, runtime with no operating system. It ran directly on the hypervisor. So they did a bunch of, really, really cool stuff. And I think there was this vision and moment where people are like, maybe we sort of let go of operating systems and let go of traditional networking and kind of move into this world. I think that revolution, I think the challenge with it though was it required you to throw away too much of existing infrastructure, right? Like if you think about like a financial institution that spent $100 billion on their existing infrastructure over their last 30, 40 years, it was too high of a mark to say, throw everything away, spend $100 billion and rewrite into this glorious future. And I think that's where it's sort of like there's that balance of the evolution versus the revolution, right? Like I think you saw a handful of people, the cloud native net new apps could be built in that way, but you couldn't bring any of the existing enterprises because the incremental cost was just too crazy for them. So I think that forced the hand of the cloud providers to say, okay, we'll give you traditional networks and VMs and all of the like stuff you're used to. And I think then the evolutionary path is we've still gone from big monolithic apps into smaller microservices, really moving to a composition of a set of, cloud provided queues and Redis and database and whatever. So it's a lot less of these big monolithic kind of orientation into microservices that are composed of these things. And I think increasingly moving towards smaller services, Lambda type things. But it was more, I think, evolutionary than maybe it could have been. But I think the practical reality is the revolution was almost never going to happen in the enterprise because the cost was too impractical. And I think there's a skill set gap. There's a learning gap. If you said, throw away everything you knew as a Linux admin for 20 years and go, now you're go learn about unikernels. Feel like, what?
Oh, I love that you brought up unikernels. I haven't heard that term in like 3 or 4 years. And when those were like a brand new thing back in like 2013 or something, I was like, these are amazing. These are going to take over the world. And they just didn't. I think containers rolled along and kind of stole their thunder a little bit.
Yeah, totally. And I think there was a brief second where we even thought about like unikernel containers. And I think Docker even bought a company that kind of focused on that. And so there was hope for a second, but then I think it was unikernels represented too much of a revolution once again, because I think everyone's struggle was like, how do you do observability on them? How do you do log shipping? How do you do security agents? And because there wasn't good answer, you're like, well, just make it a fat container and shove all of our agents into it and, close enough. You're like, okay, now it just looks like an operating system inside of a container.
You've recreated it and added another layer of abstraction that we didn't even want.
Exactly.
The other thing that I brought up to Cole was the fact that we had all these cool platforms as a service launch, but there was no consistent standards between any of them. So if I was going to adopt and go all in with AWS, that's great. But now I'm locked into their way of doing platforms. Or I go with Azure and now I'm locked into the way they're doing their platforms. And what we really needed was a governing body or something to stand up and go, okay, here's some consistent standards that all the clouds should use. And I think we're sort of approaching that with object storage. Like, as far as I know, S3 is now an open standard, and Google Cloud, I think, is compatible with it, or there's a really easy shim to make it compatible. And there's a ton of on-prem ones that are S3 compatible. Azure's kind of the holdout. And I'm like, hey, can we just universally adopt the S3 open standard for storage and maybe do that for some other things?
I thought Azure Blob Store did end up adding like an S3 compatible API. Or
there's like a Python library or something that'll do it, but it's really just a shim layer. It's not natively supported by the API.
Got it. Yeah, I mean, I take your point though, which is I think if we look back, it's like really you squint and the primitives aren't that different. Like you really look at a classic app, you're like, okay, I want transactional database, and okay, I think across most of the clouds you have a MySQL or Postgres compatible offering at least.
Right.
You want some sort of an MQ, message queue type thing. I think we haven't really seen a standard there. Like there's no real equivalence between the cloud providers and their native offerings. Kafka is probably the closest as sort of a cloud neutral protocol. Redis is probably the closest as sort of a caching layer that's sort of cloud neutral. So I think that's, if I look at kind of like the core middlewares, I think we're sort of slowly getting there between database, caching, message queue, et cetera. And then I think from a management perspective, I think that's where tools like either HashiCorp's Terraform and Vault, Kubernetes, I think those have started to fill maybe some of that infrastructure layer in terms of like what's a consistent way you run this stuff, which has been kind of almost more of a standard de facto versus one that's driven by one that's like a standards body maybe.
Yeah, and that was sort of the present day of the cloud for me is the fact that we've now, adopted these tool sets that allow us to have at least consistent tools to work across these different clouds, even if we'll never have consistent standards across all of them. Because there are certain advantages to the way AWS does something versus Google Cloud. So I may want to take advantage of the fact that Google Cloud does this thing differently and I like it better. What I would really like to see, and it's slowly starting to happen, is the adoption of these same tools on premises and the exposure of API endpoints on all the various infrastructure things that exist on-prem. And that's a very slow rolling process, and I wish it would go faster.
So I think the irony here, it's funny because I talked to so many customers who their vision over the last maybe 5 years was forget about modernizing on-prem. We're just going to move everything to cloud. So whatever, just let everything here slowly die and we'll move everything to cloud. And then along the way, I think two important things happened. One was the further they got to cloud, they were like, wait, this is expensive. And what's our business case for moving all these things here? And all of a sudden they're like, maybe there isn't one. So maybe the vision that everything is going to go 100% cloud started to fade a little. And then I think in parallel, Broadcom bought VMware. And it was like, congratulations, your price just went up 500%.
True.
And so you now have this double whammy where I think customers were like, wait, we sort of ignored our data center because we kind of figured it would just go away. And so we just didn't think about it. All of a sudden now they're realizing, A, it's not going away because of the cost reality of cloud. And B, we actually have to get off of VMware unless we, enjoy being taken hostage. So, I think now we're actually seeing a big resurgence of customers spinning up data center modernization efforts to basically say, hey, what's our path into sort of like, we're not going to leave the data center, but we want it to be more cloud-like and sort of take the learnings from what we've done in our public cloud and bring it back to our private cloud. So I actually think there's an interesting double catalyst of that's now sort of causing those conversations to pick up in a way that 5 years ago was just like not on anybody's radar.
That's really interesting. I didn't think about the double whammy that was there of cloud costs haven't really gone down, even though they've been investing like crazy. And at the same time, the VMware tax has gone way up. And so people have been reevaluating their data center strategy entirely. And that really opens the door to some new solutions. Not to be an advertisement, but like, this synergy that you have with IBM, now that you're part of IBM, that OpenShift and Terraform and Vault and all these tools working together, that seems like a pretty good potential option to move away from VMware, but still stay on premises.
Yeah, I mean, I think that's kind of a big part of the vision, which is like, I think the HashiCorp stack was always designed around hybrid. So our view was always like, why treat your data center any differently? I can use Terraform to provision, bare metal in the same way I can provision cloud. You can use Nomad to run a container on-prem in the way it can run in cloud. So I think it's a good fit into what we always sort of envisioned. I think the challenge was maybe customers just didn't care about their data center a few years ago. It's like, whatever, we're just going to leave it. So why bother? Now I think there's a real interest in it. And so the fact that we can have a common approach, on-prem and cloud, I think is becoming super compelling. You're going to laugh at me at this, but the other one that we've sort of seen that's an interesting, again, you're going to laugh, has been even IBM mainframe. Because when I look at these customers, it's like every bank, insurance company, healthcare, telco, at the core of their system is still a mainframe, and that's not going to change. And so now we're sort of looking at saying, well, why can't it be Terraform that's managing the whole end to end, right? I can manage my mainframe with Terraform, my on-premise private data center, my cloud infrastructure. Same thing with Vault, same thing with Nomad, same thing with Console. So I think there's this interesting view where it's like, okay, insofar as I'm going to modernize my data center and I'm adopting multi-cloud, is there kind of a common operating model across the whole thing, even including, infrastructure like, IBM Z, which now we're building modern Terraform providers for as well. So to me, it's like, it's not an opportunity that I would have thought about because obviously we started the company thinking about cloud, but in the context of customers saying, my reality is going to be hybrid forever, it actually makes sense.
I've always thought of cloud. Well, I won't say always. I have come to the understanding that cloud is not a location. It's a way of operating and a way of thinking about things. And one of the things that you absolutely need if you're going to adopt cloud is an API to work against. It can't be all like terminal based anymore, right? And if I think about something that is terminal based and does not have an API, or at least like a RESTful API, mainframes would probably be like top of the list. So it's wild to think that a newer IBM mainframe would support a Terraform provider.
Well, I mean, the funny thing is it's exactly that. I mean, I think traditionally that's how people thought about it, was like you file a ticket and someone goes and manually, types something into a terminal. Versus now what's happening is we're basically building a set of RESTful APIs that then you can build a native Terraform provider against and just say, great, I want to provision a VM. Because you really think about it, mainframe is basically a data center in a box, right? Like you can run 10,000 VMs on a mainframe.
Mhm.
And so all of a sudden, you're not going to manually provision 10,000 VMs, like in the same way you wouldn't manually do that in the cloud. It'd be crazy, right? So you'd want a declarative way to actually manage that at scale. It's fine if you had one or two, but once you're talking thousands, and then all of a sudden you're like, well, isn't that exactly what Terraform was designed to do? You're like, it's weird because you didn't expect the context, and it's a little bit like Back to the Future in a little bit, but it ends up being that a good fit for the technology.
So I have a
Everything
question
that's old
for
is new again.
I have a question for both of you here, because there's two sort of like views I see coming through here: modernization towards what is cloud, right, and then meeting them where they are. So Ned, before we go like into the future side of it, for some of us, a modern architecture in the cloud may be where we started. Maybe our company was fortunate. It doesn't matter, fortunate or not. Just when it started, we're able to greenfield, go right into those new architectures, those new ways of thinking. But on the other hand, we have the brownfield that are still catching up. So in terms of the ideal present day state, both Ned and Armon, do you see this as us moving everyone to this modernized architecture and working with cloud concepts? Or do you see it as let's meet them back where they are and make the workflow to interact with those systems modern?
Oh boy. I don't think, for those folks who have been in the industry for a long time, and hopefully they're open to learning, but I feel like some of them got left behind along with the data centers, right? So we stopped caring as much about the data centers because cloud was the new and shiny. And we also stopped caring about our sysadmin much. And I think it's incumbent on the organizations that are now going, ooh, maybe we want to modernize the data center. You have to modernize your folks too. And by that, I mean training. I mean showing them the way, getting them in front of high quality instructors, or if they're a self taught kind of person, giving them the time and the resources to experiment and learn basic cloud principles and the most common tooling that folks use out there. That's a huge part of it. If you want to accelerate your cloud journey, you have to start with your people, because it's people's process and technology. People is always the first one in that list. If you want your process and technology to improve, you got to start with your people. So that's how I view it. Where we are today is a lot of people kind of got left behind, and maybe they got a little grudge, a little chip on their shoulder about it. So you got to give them a moment, give them some hug ops, and then get them prepared for the next phase of their journey of modernization.
Interesting.
Couldn't agree more. I mean, I think what we see is sort of this tale of two cities. You almost have, I'll call it, the born in the cloud organizations, where, to Ned's point, they maybe hired in people that were, kind of cloud people from the beginning. And so there was no cultural transformation. They were always cloud. They did things in a cloud way. They have no legacy process. And I think those were the front runners that sort of adopted cloud early, went to scale quickly, and sort of led the way, and in many ways helped define what even cloud native means, basically. Because in the early days, it was sort of, we were figuring out what did it mean to even be cloud native. Because there was a co-evolution in some sense between the underlying cloud platforms and the tools and the process. And so it's like took a while for industry to figure it out. Then you have the organizations that predate cloud. And I think the biggest challenge there is, to Ned's point, it's a cultural transformation, and it's an upskilling of the people, right? It's like the tools now exist. We know what good looks like. You can see, cloud native companies talk about it at conferences all the time. But it's the journey. You have to kind of meet them where they're at and say, okay, great, you have everything as a manual process today. We're probably not going to immediately jump to fully containerized, fully automated self-service tomorrow.
Right.
So it's like, what's the journey of like helping incrementally upskill and change process and transform so that over time they can get there or get very close to there. But that's a lot harder because you're talking about changing hearts and minds. It's not just swapping tools out.
For both of you, then it began with people. So you think that in terms of just sort of trickled down in the sense that people weren't ready. Therefore, we had to meet. If you want to actually get their business, you've got to meet them. Thus, some of the tooling, some of the processes started affording the old ways, the legacy ways, whereas we have the cloud native ways. And like you said, the tale of two cities, which is pretty neat take on it. So Ned, my question for you then, when we started talking about the future, right? There's kind of like two futures here. One future is I still am not sure is the next future everyone moved towards cloud native, or just the concept of cloud native, that the convenience of it brought to both on-prem and cloud, whichever it is that you choose, right? Or is there another future beyond that, right? Because I know part of the future of achieving that modernization comes back to AI, right, Ned? So what did you mean by the future of the cloud?
Future of the cloud. It's really hard to say where we're going with everything. There are so many different emerging technologies happening at the same time. What I will say is what we have available to us on premises today is light years better than what was available 10 years ago. When I was, in data centers, racking and stacking and cutting my knuckles on the cage nuts, everything was completely manual for the most part. And, you wired something up and then you had to lay down an operating system. That is not how modern infrastructure that you purchase today comes shipped to you as. You have companies like Oxide Computing that will ship you at rack scale a fully running system that kind of looks like a mainframe, if we're being honest. And it has an API front end for you to program against. That's the sort of technology that we've got today. So I think the future is modernizing to these cloud operational practices, regardless of where your cloud lives, if it's on-prem, in a colo, or you're using one of the cloud providers. The way that we can get there and how AI comes into it is helping us, if you're starting from a more legacy standpoint, helping you to adopt these modernization techniques. Part of it's that analyzing what you have today, understanding your real estate in a more fundamental way, getting some help and suggestions on how to transform it. I think there's also an opportunity for AI to help be kind of a co-trainer to help you figure out how to do something. I've been doing a live stream with my buddy Marino Wijay, and we're using AI to help us learn Python to work with Amazon Bedrock, which is like a whole flywheel thing. AI is teaching us how to use AI. And it's been pretty successful. So I think there's definitely some potential there to leverage an AI system to help you learn in a way that's most useful to you, because you can ask interesting questions and get back mostly useful answers, especially if we bound it around a particular programming language or something along those lines. So I think AI is something that can help us accelerate adopting the future and sort of speed up this evolution that Armon, you were talking about.
Totally. Yeah, I agree with you. I mean, to me, I think it's about closing the skill gap. And I think in a lot of cases, it's how do you actually add layers of sort of abstraction that simplify what you need to even learn? Like, I almost think about it as like the evolution being from like when we were racking and stacking, in a data center, you were almost like you were assembling your car. Like, right? Like buy a bunch of pieces and like, mount the engine in and like figure it out. To eventually, okay, if you're just running on cloud, you're sort of like driving the car, but with like a manual transmission, right? You still kind of had to know what you were doing. So it's like, okay, and then the next step of it is like, can AI sort of hide some of that? And it's like, okay, are you driving with an automatic transmission? Now you don't have to think about that. To eventually, it's like you're just getting in a Waymo and saying, this is my destination, right? It doesn't mean that the technology went away. There's still a car, there's still a transmission, there's still engines, and all those pieces are there. But I think your experience of it moved up into much more of like, well, my outcome is I just wanted to go A to B. I didn't really want to sit here and assemble a car. Right. And I think that's the evolution we're sort of going through. And today I feel like we're almost at the like automatic transmission phase versus it's like, okay, well, what does it look like to get to the Waymo phase?
Yeah. I think one of the big challenges is going to be building trust in the AI tools that come out. Because today, I can only trust about like 50% of what Copilot tells me when I ask it to help me write code. It's gotten better. It used to be like 20%. Like, I'll ask it to write me something in Terraform, and last year or like 2 years ago, it was like 80% wrong. It was mixing and matching provider versions and making up resource types that didn't exist. Now it's like 80% right, but it's still, I know I have to double check it. I know I have to dive into what it's capable of. What I'm envisioning is a point where I don't need to check it. And in fact, maybe I don't even have to directly manipulate Terraform anymore. Terraform is the thing that's being used under the covers to provision my infrastructure. And the AI tooling is assembling that for me, maybe through a catalog of modules or something along those lines. So I'm not assembling the car from scratch. I'm not inspecting every weld. I am just getting the car and getting in and driving. Can we take it one step further? Absolutely, we can. But like you said, we just need to get to that point where we're no longer driving a manual transmission car. Maybe we've got an automatic transmission and some like level 3 self-driving.
Ooh, like that. What do you
No,
think, Armon? I'm waiting for
I
you.
totally agree. I mean, I think that's I think that's where we got to head to.
Yeah. So my question with, even if it gets to that level, right? So even we see this with Vault, right? The whole machine to machine, you don't need manual approval anymore. That sounds awesome until you put it in someone, they're like, wait, that makes me feel uncomfortable. Like, hold up. That's cool, but I still need the confidence. I still need to do it. And you have to go through this process of saying, look, it's okay. Let's open up the black box on. Here's exactly what's happening. Here's how you know you can trust it. Even if we do get to that point, what are those hurdles in terms of building the trust around, okay, look, you've got this, Ned, you talked a big part of this about being migration. Let's get to that present day for where you are, on-prem or cloud or not. Let's get migrated to it. Let's get all that work done. We can think strategically and let the execution be left to AI, but we still have to trust it. Even if it is 100% accurate, how do we get to that point to where we can, even if we have the tools, people will still use them because they trust that they'll actually do what they're supposed to.
Armon, you want to take this one?
Sure. Yeah. I mean, I think this has been even without AI, I feel like we've seen this similar challenge with things like Vault for years as we talk to customers, right? And I think, almost the framework I like talking through with people is thinking about security controls, for example. You can almost think about it as like there's two dimensions. On one dimension, you have basically, I'll consider a high-level intent, right? You might say, hey, service A is allowed to talk to service B. It's kind of like a logical thing. I intend service A might be my web server, to talk to service B might be my database. Great, that's a logical thing. But then you have the other dimension, which is control, right? And so you might have physical controls like, well, the database has a username and password. You have to present that for it to be able to authenticate. You might need a certificate to establish a TLS connection. There might be a firewall in between that needs to say IP1 to IP2 is allowed. So all of those are physical controls, but they map back to a logical intent. Right? If I'm saying my web server can talk to my database, okay, that means it needs a database credential, it needs a certificate, the firewall needs to be open, right? One implies the other. But if I look at the way organizations have managed things forever, they've never managed intent, they only manage control. So you can go to them and say, well, show me your 10,000 Oracle service accounts, and they can show you that. You say, show me your 1,000,000 firewall rules, and they can show you that. And then you say, well, show me what apps are intended to talk to what other apps. Blank stare. No idea what app is meant to talk to anything else. And so I think, to me, what that speaks to is like, it's a philosophy change of saying, okay, well, in some sense, managing the list of saying A can talk to B is really no different than managing the set of firewall rules. But you've got used to managing it at the wrong level, right? Like you were sort of writing assembly code, and now we're like, no, you should just write Python and the assembly will be auto-generated for you. And in the same way, I think people sort of fought every one of those abstractional changes. It's the same thing. When you make that shift to Vault and say it's a dynamic secret, Vault's just going to generate a new database secret every time. You're just authenticating saying app A can talk to the database. Do you actually care what the username and password is? No. In practice, the answer is no, you don't care. But there's a process and a culture shift saying, okay, I'm moving from managing control to managing intent, right? And once they get there, every organization's like, well, this is 1,000,000 times better because who cares about the 1,000,000 firewall rules? but there's a cultural shift they have to go through.
Yeah, there's the same sort of shift that happens for folks that adopt cloud networking in any of the AWS or Azure. You come with it with these preconceived notions of how networking works, and none of it actually works that way under the covers. It's all software defined networking. Hosts talk direct, or VMs talk directly to each other. They don't send it through a router and a gateway and a firewall unless you make that happen. And you can really slow down your networking in the cloud by applying these older concepts to it. What was your intent? Like you said, I want this service to be able to talk to this service. That could be a simple security group rule in AWS, and it doesn't have to be any more complicated than that. You don't have to segment it across two VPCs with a firewall sitting in between and all this other stuff. So it is sort of changing the paradigm in people's heads of what was your intent versus how do you actually go about implementing that. The other thing, if we want to increase adoption, we have to, trust but verify and have robust auditing tools. So being able to show that yes, in fact, this service can talk to this service and no other services. So I need to be able to verify that my intent is what was actually implemented through whatever auditing tools are available for that. And once you can see that and validate it, I think people will feel much more comfortable about letting go of the reins a little bit, as long as they can show and prove to somebody else, like an auditor or something like that, that yes, in fact, our intent is being implemented, and here's the proof of that. I
Yeah,
like
I think
that.
it's critical. Yeah, that translation of the intent to the control has to be auditable so that you can build trust in.
And the AI tools in the same vein, I need to be able to trust and verify that the AI tool did what it said it was going to do.
Mm.
One of the cool things that at least programming AI stuff can do is it can write tests for you. And that's super nice because writing tests is awful and very boring. So if I can say, hey, you wrote this software, and then ask a different model, please write tests for this software to prove that it actually works. I can vet those tests, and then I can vet the software and go, yeah, okay, you did what you said you were going to do, and you checked that. And I'm just the person in the middle that is expressing the intent. What did I want the program to do? And then verifying that the program does what I expected.
In many ways, I actually think even the future of software development becomes intent driven. Um, I spent a bunch of time with Guy Pajerny. He was the former founder of Sneak. He's starting a new AI company around exactly this thesis, which is basically, if you think about what most software is, you start with a product manager who says, here's a set of product requirements, right? User pushes this button and it should send an email with blah, blah, blah. That's an intent. I mean, that's for all practical purposes. And then we're giving it to an engineering team to go write the implementation. Anyways, it's actually not that different from saying, well, you've defined the intent. Why can't the AI generate the implementation? And to your point, if you have the right guardrails around, okay, well, there's a test framework that actually validates the implementation matches the specification, then in many ways, to me, I think that's where the future of a lot of stuff should go. It's like you're probably not going to use that to write your database, but for most of our applications where it's like a basic RESTful API doing some CRUD type stuff, it's like, why can't I just specify the behavior of the API and it just auto-generate the API controller itself?
Yeah, and when I think about like the frameworks, like the JavaScript frameworks that people use, and the amount of stuff that's like crammed into there that you don't even know about, you trust that. Like, I would actually rather have an AI write something from scratch than use a really bloated framework that I don't really understand all the components of, because at least I can kind of check what the AI wrote. I'm not going to look through the 36 modules that make up this framework.
The 27 megabytes of JavaScript that get pulled in for React.
React to load one web form.
Right. You're like, this is a lot of overhead for a button.
It's interesting because in the AI thing with natural language and the whole conversation of intent, I feel like intent is very human too, right? Because when you're at your most frustrated debugging a problem, if you're the programmer, the operator, it doesn't matter. What do you usually scream at the screen? Usually the intent. You're like, I just want this to talk to this, right? So now we can just get right to that. All right, we're coming up to the top of the hour here. I really appreciate having you both on, Ned. I know that that you didn't quite know we were going to have a special guest on today. And obviously, I'm so happy to have you on, Armon, as well. Ned, Armon, did you have any last thoughts? Did you have any questions for each other you wanted to ask here before we end it?
Well, I mean, first of all, thank you, Armon, for coming on. I always enjoy having a fun conversation with you. And I just want to say congratulations on the acquisition. And I'm really looking forward to seeing what happens over the next year, because I know you've had a lot of intent bottled up, and now you now you get to release that.
There we go. I appreciate the callback there. No, I'll say the same thing. A huge thank you to you, Ned. Obviously, been a huge member of our community for a very long time, and I know probably a lot of people on the call similarly. And we're excited. We couldn't have gotten here without the support of our community, and we have a lot of good stuff in store over the next year or two, and excited for it. Should be fun.
I do have one more thing to promote, if you don't mind. Me and my co-host Kyler Middleton over on Day 2 DevOps are doing a fundraiser for the Trevor Project. So if you go to day2devops/hugops, you can get a t-shirt from Day 2 DevOps, and all proceeds are going to the Trevor Project, and I am matching the funds.
Ooh, very nice. In fact, just to make sure that we all see what that is here, I'm going to flash that on the screen, right? So you just go right there, Day 2 DevOps. You can check that out. All right, everyone. Thank you so much, Armon and Ned, for coming on, sharing your thoughts and ideas. Thanks to everyone who's joined us and participated live, or if you're going to watch us after the fact. This is going to be up on YouTube and even LinkedIn after the fact. It'll even be on Twitch. In fact, we've been on Twitch. There's even been some questions on there about Nomad, which I was going to plug, but we're out of time here, so we'll leave that as it is. I look forward to more episodes of our HashiCorp Ambassador Thought Leader series. And I know the next one's going to be in March, but until then, thank you, everybody.
Thanks so much.
Everyone.